So in today's video, we're going to be looking at on how we can differentiate sine x and get cos x using the first principle. So this is an exam favorite question. Usually is worth 5 marks. So it's really important to know on how we can do this type of question here. So as always, let's start. So what's my sine x? That's my f of x is represented as my sine x. And my sine f of x plus h can be represented as sine bracket x plus h. And we can use the expansions here that we have that is given in the formula booklet. We can expand this as the following, as sine x cos h plus cos x sine h. So that's my expansion done. So now let's substitute everything inside the formula. So the formula goes f dash x is equivalent to, as the limit of h goes towards 0. Not yet, but we'll have a look at that later on. So my f of x plus h is the expansion that I've got here. So I'm going to substitute this here as sine x cos h plus cos x sine h, close bracket, minus my f of x, which is simply sine x. This is all over h. So the next thing I'm going to do here is get all the sine x together and everything that does not have a sine x separately. So again, my limit of h goes towards 0. In this case here, the equation I'm going to get together is this part and this part here, as they both have sine x. So I can rewrite this as sine x cos h minus sine x plus, I can keep the other part the other side, so which will be cos x sine h all over h. So now there are two things I can do. I can split this fraction into two fractions, where one of the fraction we're going to look at all the sine x together as one, and this the cos x sine h as the other equation. So let's have a look on how that would look like. So we can write as the limit of h goes towards 0. I can rewrite this as sine x cos h minus sine x all over h plus cos x sine h all over h. So from there, what we can do here now is simplify out and take some of the factors that are the like terms out as well, just so that we can see exactly what we need to do. So as the limit of h goes towards 0, if I take a factor of sine x out, given that sine x is a factor here, so I'm left with simply, I'm going to rewrite this as cos h minus 1 all over h plus, in this case, there's really nothing to factorize, but we can take out the cos x out, and that leaves us with sine h over h. So as the limit of h goes towards 0, we know some stuff, which means that sine h goes towards h. This is again using the small angle approximation, and the other one is and so therefore if sine h goes towards h, then that means sine h over h will go towards 1, as we get h over h, which is equal to 1. Very similarly, we can replicate for the other part as well, which is cos h. So cos h turns into, again using the small angle approximation, to 1 minus a half h squared. Again, this is using small angle approximation that is given to you in the formula booklet as well. So therefore, what does that mean? So simply this means for cos h, so that will become 1 minus a half h squared minus 1 all over h. 1 and 1 cancel out, simply leaving with minus a half h squared over h, which gives us minus a half h. So, and therefore this turns into 0, because as we said, h is going towards 0. So just to summarize, going back here to finish this off, so this simply becomes sine x bracket cos h minus 1 over h. We proved that that gives us 0, so that'll be 0 plus cos x bracket, and we know the sine h over h gives us 1, and therefore that would be 1, so that'll be 0 plus cos x, leaving us with an answer of simply cos x as our final answer. So this is how you prove the differentiation of sine x is equal to cos x using the first principle. Let me know what you think of this question below.